We're going to continue graphing rational functions with transformations. Today we're going to add in the dilation and also focus on the translations in addition. So the first one here, we have y is equal to 4 over x. So we know that it's a rational function or reciprocal function because that x is in the denominator. We have a 4 in the numerator, meaning that our original function of 1 over x must be multiplied by 4. So if we have that multiplication, we're going to say it's a vertical dilation by 4, which means that the y values are being multiplied by 4. So if we just set up a really quick table of -1, 0, and 1, we plug in those values for our parent function of 1 over x. So if we plug in -1, we get -1. We plug in 0, we get undefined. We plug in 1, and we get 1. If we multiply our y values by 4, then we end up having -4 and 4. So if we plot our new points of -1, -4, and 1, 4, so -1, 1, 2, 3, 4, -4, and 1, 1, 2, 3, 4. These are the points that we're going to have our graph go through, but let's start by putting our asymptotes on. So remember, our natural asymptotes, unless they've been translated, are at x is equal to 0 and y is equal to 0. So here is y is equal to 0, and here is x is equal to 0. And then we're just going to do the general shape of the rational function. It's not perfect. It's going to follow the lines of the asymptotes. Let's finish it off by writing domain and range. So our domain is x cannot equal 0, and our range is y cannot equal 0. Let's look at the example 2. So first we're going to identify all of our transformations because we have 3 different transformations happening here. We have that vertical dilation by 3, so the y's are going to be multiplied by 3. We have a translation to the left by 2. So remember, anything attached to the x is the opposite of what you think. And then we have a reflection in the x-axis. So let's set up our table, x and y, -1, 0, and 1. If we plug in, remember our original table is always for our parent function. So we plug in -1, we get -1, we plug in 0, we have our asymptote, we plug in 1, and we get 1. Then we're going to apply our transformations. So the y values, they're being dilated by 3, but they're also being reflected. So we have a negative there, and our x values are going to the left by 2. So we're going to subtract 2. So let's look at our x's first. We have -1 minus 2. That'll give us -3. And then we have -2. And 1 minus 2 is -1. Our y values, so just to be clear, this is going to be our new asymptote. With our y values, we're going to take -1, we're going to multiply it by -3, so we get +3. We're going to take 1, and we're going to multiply that by -3. So we're going to plot our new points and our new asymptotes. I always like to start with the asymptotes. So our original asymptote at x is equal to 0, so I'm just going to draw a small dotted line just above at x is equal to 0 because it doesn't exist there anymore because it was shifted to the left by 2 units. So now it's going to exist at x is equal to -2. The original asymptote at y is equal to 0 has not been shifted up or down, so it's going to remain at y is equal to 0. Then we can put our new points in, -3, 3, and also -1, 3. Or sorry, -1, -3. Then we're just going to follow the curve of the asymptotes. And do our domain and range. So for our domain, the graph does not exist where the vertical asymptote is. So x does not equal -2. And for our range, the graph does not exist where the horizontal asymptote is. So y does not equal 0. In this question, we have two different transformations. We have that vertical dilation by 2. And we also have it shifting up by 2. So going up by 2, that's going to impact our horizontal asymptote. If you want to put your asymptotes on first, then that's fine. So normally it's at y is equal to 0. And we're going to move up by 2. So our new asymptote is going to be at y is equal to 2. And we have nothing shifting left and right, so that means that our original asymptote at x is equal to 0 is going to remain there. Okay, go away. Sorry about that. So we'll start with our table of values of our parent function, which y is equal to 1/2, or 1 over x. Then we will do our y plus 2, our translation up, and our vertical dilation means that we also have to put a 2 in front of the y. -1, 0, and 1. Our original, we would have -1 and 1. We take -1, we plug it into our new expression for y. So -1 times 2 is -2, plus 2 is 0. We plug in 1, 2 times 1 plus 2 is going to be 4. So when we plug those in, -1 and 0, and 1 and 4. Then we're just going to do our curve. Nothing too beautiful. And our domain and range. So x does not equal 0. So remember that is our vertical asymptote. And y does not equal 2, which is our horizontal asymptote. Now we are going to default and say that all of our dilations are vertical dilations, and we're just going to do that for consistency. You do have horizontal dilations with rational functions, but we are only going to focus on the vertical dilations. So if I was to separate this to see that vertical dilation, we could say that it's a vertical dilation by 1/3. So that means if I take my x and y, -1, 0, and 1, -1, asymptote 1, we're just going to multiply those by 1/3. So our x and y asymptotes, those vertical and horizontal ones, are going to stay the same. And then we're going to plot our new points. So our domain, x cannot equal 0, and our range is y cannot equal 0. The last question we're going to look at is rearranging this equation into our simple rational form so we can graph it using transformations. So we're actually going to use long division. So we're going to divide x plus 4 and 3x. So x goes into 3x 3 times. So after we multiply those, we get 3x plus 12. And then we're going to subtract. 3x minus 3x is 0. 0 minus 12 is negative 12. So that means our answer is 3 plus negative 12 over x plus 4. So see how using long division and our solution to long division with our remainder is actually rearranging our question into transformation form so we can graph it. So that means if we identify our transformations, we're going up by 3, left by 4, a reflection in the x-axis, and a vertical dilation by 12. So I paused it just to give back some time here, and I made my tables. If I plug in -1, I get positive 12 plus 3, so 15. Negative 12 plus 3 is negative 9. Then I take my x values and I subtract 4, so I get negative 5 and negative 3. So I will draw my asymptotes and I will graph. So my first asymptote is going up by 3 and left by 4. And then negative 5, 15. So this is kind of going to be a little bit challenging, but it will be way up off my screen, kind of up here. And negative 3 down here. So the graph is going to be in the bottom right. And if I erase this a little bit, it will also be in the top left. So my domain, x cannot equal negative 4, and my range, y cannot equal positive 3.